Replace a bunch.
Can you behave yourself?
Did you run out of memory?
Alright, so to do a quick summary, we're finding the volume, okay, so we're finding the area underneath the curve and we're rotating that around the x-axis, okay. So we'll take a strip of delta x here, okay, and then as I make that close and close to 0, I'm finding the area of the circle that is formed when I revolve it about the axis. The idea is I'll take an infinite number of those circles, area circles, and then when I add them together, I'll get the volume formed that way. So we need y squared the subject when we integrate with respect to the x-axis. So pi integral from bound b and a, y squared. So we looked at the formula, it almost looked like the radius of the circle. That's because this distance here is of course y, and we're finding the value for that radius there. So the first example here, if we've got that rectangle portion being rotated about the x-axis, and we've already established that that's going to be a cylinder. So, pi 25 lots of 4 minus 25 lots of 0. Okay, so 25 4 is 100. So the volume of revolution, we're going to keep it as pi, because it hadn't asked us to approximate. So unless it's asked you to approximate, you need to leave it as pi. Okay, and then it's units cubed.
Why is that good? That's disappointing.
We're just getting started, Robin. Right, who remembers the formula for the volume of a cylinder? Yep. Okay, so the volume is pi r squared height. What's the radius?
5.
Yep, 5 times 5 squared. And what's the perpendicular height? 4. Pi times 25 times 4.
Wait, wouldn't the radius be? No, yeah, 5.
Because we rotate it this way. Okay, and that's why it works. And that's how they discovered how to find volumes.
Wacky. Awesome. That is quite wacky. Don't. Oh, kidding.
Got time for another one?
Smashes the button.
Right, B. The line y equals 2x. Rotated about the x-axis. This is rotated, so as soon as you see the word rotated, you are finding volume. Between x is 0 and x is 2. Find the volume of solid of evolution formed. Okay, step number 1. Okay. Now, we're bound for base in the first quadrant, so I just need to consider the function in the first quadrant, y equals 2x. So the y-intercept is 0 and a gradient 2 from 2 to 0. Okay, so we're finding that volume as you take a strip for the radius and you rotate that about the x-axis there. And it is a cone. Okay, when you take that and you revolve that about the x-axis, the resulting solid form is a cone. Alright, so volume is pi from the integral from 2 to 0. Okay, and remember, when we need the volume, we need y squared. The subject, when we're rotating about the x-axis, and then of course, when we're rotating about the y-axis, we'll need x squared, the subject. Right, so y equals 2x, so you need to have y squared set up. Okay, so y squared is going to be 2x all squared, so 4x squared. Okay, so the only difference between your areas that you've done, you need to include pi at the front, and you need y squared or you need x squared, the subject, depending on which axis we are referencing. Now, because of the constant number I'm multiplying, I can also move the 4 out the front, okay, because otherwise it's just going to be a factor of both the things I need inside the bracket. Because I'm multiplying or dividing, I can do my factorising skills by factorising at the front, and I can just integrate x squared. Alright, so x cubed on 3, bounded from 2 to 0. Okay, so you can keep it like that. You can keep the 4 there if you wish, alright, or you can factorise it out. So I'm going to. Okay, so again, I'm dividing by a constant number, so I'm removing that right out the very front. And all I need to do is substitute in for x cubed, because it's going to be a factor for both the terms in there once I've finished. So 4 pi on 3, we have 2 cubed and 0 cubed. So 4 pi over 3 times 8. So I have an answer of 32 pi on 3. Okay, so unless you're told to approximate, you're going to leave it in terms of pi. Right, does anyone remember the formula for the volume of a cone?
It's 1.5 pi squared.
Good. Okay, so it is a third because it's a regular, because when you enclose it, it becomes a regular prism, as in a cone. Oh, there you go.
He pointed it out, yet he still got it wrong.
Why is it a third?
Because it forms a third of the equivalent volume for a cylinder. Okay, so a third times pi, what's the radius?
4.
Is it 4?
2.
What's the radius of the circular base?
The biggest, the base is 4.
The base. No, not 4. That would be the diameter.
No, 2. No, would it be 4? No. Because it's that far, and then y equals to r is x squared.
Yep, that's the base here from the centre to the circumference.
The y would be 4. So it would be 8.
So,
What? I'm lost now.
The y, the 2 equals.
oh, okay, yep, sorry.
So it would be 8.
So that would be 4, yep. Sorry, I'll get what you're saying. Apologies. What's the perpendicular height? That's what I was thinking. How far is it from here to here?
Which cylinder are you doing?
So,
Which
The
cylinder?
bottom, what do you mean? Which side?
the radius of the bottom circle for the base.
Why is it 4?
Because this is y equals 2x.
And at 2 it's...
These two will be the perpendicular height.
So at 2 it's going to be 2 times 2.
Yep, for the radius, yep. And the perpendicular height from 0 to 2 is 2. Okay, apologies for that. So what is 4 squared? 16 times 2, 32 pi all over 3. Okay, that's how they developed these formulas. So what you've learned in year 8 or year 9, whenever you learned it, okay, came from integration.
They use this to get those.
Yes.
Or do they use those to get this?
They use this to get those.
Well, that is.
That's what I'm saying. What you've learnt in year 8/year 9, whenever you learnt the volume of a cone or the volume of a cylinder, etc., it came from someone discovering integration
What
first.
have we been learning for the past 12 years at math? Like,
It's all led up to this.
we
It all
spent
come
6
together.
years learning
Don't you worry.
maths.